You had breakfast? Okay. So let's begin by praying. Okay, so let's bow our heads in reverence and let's start with a prayer. O Lord, thank you for giving us the opportunity to see a new day. We honor and praise your precious name. We ask for guidance throughout today's lesson. Please grant students with the understanding and knowledge so as to achieve our objectives. We ask for each and everyone here in today's class. As I mentioned, please help us throughout this lesson. We pray in the name of your Son, Jesus Christ. Amen. Okay, so remember our basic rules. What are our basic rules? Anyone remembers our basic rules? Be on time, no eating, turn on your cameras, mute your microphone, self-confidence to share, and be respectful. So, to start our class, for the first 10 minutes, you will take a look at the video based on the vision, right? Some of you did not um, completed the activity correctly today, so I decided to have a little video for you to guide you on the vision, and then we'll start the class content, right? So the first thing that we are going to do is take a look at the video.
In this lesson, we're going to learn how you handle problems like that. The good news is that you kind of already know what to do. You just may not realize it yet. To see what I mean, have a look at these two division problems. They both have the same dividend and both have a one-digit divisor. But these divisors are different numbers, and as you'll see, that's going to affect our digit-by-digit division process. To solve this first problem, we start by asking, how many 2's does it take to make 5 or almost 5?
Moment, I'm having some issues. Okay, now let me continue.
Or you can think of it as how many 2's will fit into 5. And it's easy to see that the answer is 2. So we put a 2 as the first digit of our answer. Then we multiply 2 times 2, which is 4, and we subtract that 4 from the 5, which leaves us a remainder of 1. Now we move to our next digit, and we need to bring down a copy of it to combine with the remainder from the first digit. Then we ask, how many 2's will make 12? That's easy, 6. So we put 6 as the next digit of our answer. 2 times 6 equals 12, and 12 minus 12 leaves no remainder. And finally, for our last digit, even though there is no remainder, we can bring a copy down and ask, how many 2's will make 8? And the answer is exactly 4. 4 times 2 equals 8, which again leaves no remainder. There, we went digit by digit and broke our problem up into 3 division steps, one for each digit. And we got our answer, 264. Now let's solve the next example. And right at the start, you'll see we have a bit of a problem. When we ask how many 8's does it take to make 5 or almost 5, the answer is none. And that's because the first digit, taken by itself, is less than the divisor. 8 is too big to divide into 5. So what do? Well, instead of just trying to divide the first digit all by itself, let's group the first 2 digits together. If we group the 5 and the 2 together, then our first step will be to ask how many 8's about 6 times. So we'll put a 6 in our answer line, right above the 2. Why does it go there? Because we had to skip the first digit and group it with the 2. If we wanted to, we could have put a 0 above that first digit, since the 8 wouldn't divide into it any times. And if that helps you keep track of which answer digit you're on, then that's a good idea. but it's not required. So 6 times 8 equals 48, and then 52 minus 48 gives us a remainder of 4. Now we only have one digit left to divide, so we bring down a copy of it to combine with the remainder and ask how many 8s will make 48. We know the answer to that is 6 also. 6 times 8 is 48, which leaves no remainder. There, our answer is 66. Did you notice the difference between these two problems? We wanted to go digit by digit in both problems, but in the second problem, the divisor was bigger than the first digit of the dividend, so we had to start out by going 2 digits at a time in that case. And that
So that is a little revision on division. So I hope you take a look at the video, because now you will do 2 problems based on division. I notice many of you are having a little trouble with division, so we need to do this. Okay, I'll give you, let's say, 2 minutes to work on these 2 questions, and then we discuss our answers. Remember, the video said you could go digit by digit, but if that is not the case, you jump to the next question. Okay, we will do the waterfall for these questions, right? So type in your answer for number 1 and do not send it until I count to 3. Right? We'll send the answer for the 2 questions. Number 1 and number 2, we will send our answers here. Right? So at the count of 3, have you finished typing your answers? At the count of 3, we will share our answers. So 1, 2, 3. Okay, very good. Okay, we get 1,406. Very good. Many of you got this one. I just saw one person with 146. Remember, you are missing a 0. That means you are missing a little step there, right? So let's send the answer for the second question now. What is the second question? Let's type in our answers, and at the count of 3, we will send our answer. See? 1, 2, 3. Okay, very good. The answer is 151, right? So the answer is 151. Remember, this PowerPoint is in Google Classroom, so you can access the video, you can access the PowerPoint. So moving on into this lesson, let me start by asking, what are the four basic operations? What are the four basic operations? Okay, Ernest has a answer there. Who else wants to share? Addition, multiplication, division. Yuri also gave her idea there. Adding, subtracting, dividing, multiplying. Very good. So the four basic operations are addition, subtraction, multiplication, and division. Those are the basic operations that we have in mathematics. Now, how do you call those things that I have in here? How do we call this? Anyone has an idea how do we call these things? Very good. These are symbols. Very, very good. So if you know that these are symbols, do you think symbols can represent operations in mathematics? Do you think that that can happen? How is this possible? Or why is it not possible? Many of you say yes. How, if it is, your answer is yes, how is this possible? How can symbols represent an operation in mathematics? Ha! Here comes the trouble, right? We can say yes, but how? How is this possible? Nobody has an idea how is this possible?
Yes, miss.
What do you think, Ernest?
I think like past 2 weeks, miss, we were using symbols to change numbers, miss.
Okay, good observation there. And Gerald says because it's used for various operations. Okay, so let's take a look. In today's session, we will take a look how is this possible or how is it not possible. Very good, Isari. Isari says because each symbol has a representation, right? So moving on to what we are to cover today. Listen to this. The operation, we have a little asterisk there, means dividing the first number by 3, then subtracting the second number from the result. What do you think about this sentence or statement? What can we come up with when we hear this? The operation asterisk means dividing the first number by 3, then subtracting the second number from the result. What is happening here? What is it telling you? What information can you gather from this statement? I'll give you a hint. How many operations does this statement has?
2.
2, right? It has dividing and subtracting. It has two operations. So what can we say about the symbols? Can't we see that it is some mixed operations? Who agrees with me? We can see that it, yeah, it is a mix of operations. Why? Because we have division, then we have subtraction. So how do you think we call this? How can we call this broad idea of giving an asterisk to different operations? Now, that is a difficult question, right? So, in today's class, we will discover what this is and how do we perform calculations about it, right? So, um, that is a good observation, but I don't think this can work in today's class, right? But let's take a look at what our concepts are. So we call this defined arithmetic operation. Why? A defined arithmetic operation is a way of defining a combination of the basic operation. We noticed that we had mixed operations, right? So it is a combination or the inclusion of other mathematical operations into a specific problem. It tells you exactly what to do. The one that I just read to you had it that you divide and then subtract. So it is a combination. It is not only addition, subtraction. It is a combination of operation. It can be addition with multiplication, addition with subtraction, subtraction with division, and etc. Right? That is how it happens. Now, I have another example here. We have a little I don't know, I don't really know the name of this symbol, but it is a little symbol there, means add 4 to the first number, then add the result to the second number. So do we see it is defined? Yes. Why? Because it is telling you the exact things. It is telling you what needs to be done, and it is an inclusion of another mathematical operation in the problem, right? It is not only addition, subtraction. It has an inclusion of another operation there. Do you have any questions? No? Many of you say no. If you have any questions, feel free to ask. Okay, so we can move on, right? So now, undefined. If we have defined, then that means we have undefined. But what is undefined? An undefined arithmetic operation involves the basic operations. The basic operations are straightforward and that should be no further calculation. Sorry about this. Why? Because it is only 3 plus 3, right? We do not have an inclusion of another operation there. It is basically the 4 operations. Why? Because it is straightforward. It is telling you to add, it is telling you to subtract, it is not need anything else than that operation, right? So that is for undefined. Remember, the defined, it is a combination of operations. In this one, it is just the basic operation itself, right? solve defined arithmetic operations. How do we solve them? If we have the previous example, that little symbol means add 4 to the first number, then add the result to the second number. So we go by what this is saying. So if it tells you add 4 to the first number, and we have 3, the little symbol, and 2, then we have to add 4 to which number? Which is the first number here? Because it tells me add 4 to the first number. So which is the first number here? 3. Very good, right? So we add 4 to the 3 and we have a 7. Now, what does the statement keeps telling me? Add the result to the second number. So I will add my result to the second number. So which is my result? 7, right? So I will add that 7 to the second number, which is 2, and we have our answer, which is 9. So it is very straightforward. The question will tell you what exactly to do, which operations to use, right? Any questions? No questions? Do you want me to repeat something? If you want me to repeat something, please say so. Is reset into this class? Let me take a look. Ryan says it's like standard 4 work, miss. We cannot say that. Why? Because there are still some students that need help with this. Although some of them might not say it, many students have little struggles with mathematics, right? So no questions? I don't think Lisette is here, right? No. Who said? Miss, will you give examples, says Yuri? Yes, this is an example. Right now, you will work on some more, and then we will discuss if you did it correctly or if you did not did that correct, right? So these are your practice questions. We have the little asterisk means divide the first number by 2, then subtract the second number from the result. So we'll do this. I think we can take like 4 minutes, and then we will please record every step that you do in your notebooks. If I did this first, second, third, because you will share using your cameras, right? So let's do that. You have 4 minutes. You are to do A, B, and C. Let's say you have write A, do your little calculations, show your steps, then jump like 2 or 3 spaces, how many you want, do B, and so on, so that when you share, we can see your steps clearly. Have 2 more minutes and then we start sharing. Please, some of you that are finished, if you are finished, let me know if you are finished so that we can start sharing. Um, I, Ryan, if you cannot turn on your camera and have share, I mean your example with the class, because what we want you to do is not just share your answer, but to tell, I did this, and this is how I got my answer. That is what I want, right? So if you can share in your um by using your camera, that is correct. But if you can't do that, that is also okay, right? So you should have finished by now.
Finish, Miss.
Okay, many of you say have finished. Okay. So, who wants to volunteer for A to show their work and to explain what they did?
Can I do so, Miss?
Okay, let's hear Ernest for A.
Can you see it, Miss?
Yes, yes, I can see that. Can you tell me what did you do?
I did half of 64, Miss, is 32, Miss. Then I subtracted 11 from 32, Miss, and I got my answer.
Why 11? Or is that
Because
21?
it's 21, sorry, Miss, and I got 11.
Okay, very good. Who wants to share B now? No runner for B? Ryan, handwriting is not an issue. Why? We will try to understand, of course. We will not. Gerald, you don't want to share your by using your camera. Ryan. Okay, let me see who wants to share using the camera, either B or C, and then we go to the chat box if no one. Okay, Gerald. Could you put it like a little higher or straighten it? We have, what is that, 30? I cannot see clearly. Is that 30, 39? I really can't see it. Yes, yes, Gerald. And then you subtract the 59. Very good. And what is your result? It looks like it freeze. Well, in my screen, it kind of freeze, right? But that is correct. We divide the 142 by the 2. We get our answer and we subtract our answer. We subtract the second number from our answer, right? So anyone for C? Let me see C. Oh, you were showing C. Okay. That is, I think 78, 39. Yeah, that is correct. The one is correct. So anyone wants to share B? Since Gerald showed C.
Can I show it now?
Yes, sure, Loriani. Can you explain what you did?
I divided 2 and for 142 and give me 71. Then I subtract 71 to 59 and give me 12.
Okay, we subtract 59 from 71. Very good. That is correct, right? So in this practice questions, you need to follow directly what the statement is telling you. The symbol tells you to divide the first number by 2. So we divide 64, 142, 178 by 2. That is our first step. Then we subtract the second number from the result. So we will subtract 21, 59, and 19 from any answer that we got, dividing the first number by 2. That is basically what this tells you to do. Any questions? No questions?
No, miss.
I just heard Ernest and Loriani in the chat.
No, miss.
Okay, Yuri, this practice is found in your activity. These questions are taken from your activity 1. So that means that this is in your, activity 2. So that means that this is in your assignment. So you can go to the document in Google Classroom and you can work that out. Let's see, tomorrow, if you have any questions, you can ask me, because right now it's just, we have just 10 minutes to finish our class. So
Miss,
what, yes, who was it?
um, last yesterday I was checking mathematics activity one, activity two,
Yes.
and on the bonus question, I don't think there is no method for that.
um I will take a look at it. Miss Maya and myself will take a look at it, because I don't remember that one. Activity 1 or activity 2?
Um, the second activity.
Okay. Using the numbers, create one expression that equals to 6. Who says, we will take a look at it, and I will get to you tomorrow for that, Alan. But thank you for the information. Okay, Ryan, let us have Ryan show his work briefly, and then we will wrap up our class session, right? Okay, Ryan has step by step. Okay, very good, Ryan. I can see your division. Very good. Please practice your division methods too. And Yuri, as I mentioned, these are found in your activities. So if you want more practice questions, those are there. I just changed a little bit of the numbers, but that is. Yeah. So to wrap up on today's class, what is a defined arithmetic operation? Can you describe it? What is a defined arithmetic operation? Let's see if you are paying attention. What is a defined arithmetic operation? You can either type it in the chat box or unmute yourself and say it aloud, right? If no one wants to share, that means that no one remembers the definition. What is an
Miss,
yes?
a defined arithmetic operation is a combination of a operation.
Could you repeat, Ryan? I couldn't hear you. I don't know if my internet is unstable. Ryan, are you here? Or I think he might lose connection. So who else wants to share what is the definition of an arithmetic operation? I mean, what is a defined arithmetic operation?
A way of defining a combination of operations.
Okay, very good. It is a combination of operation, not an operation of operations, right? So if we see that we have multiple operations in a statement, that means that we are using defined arithmetic operation. So what is a non-defined arithmetic operation now? What is an undefined arithmetic operation? Okay, good, Yuri. So it is what did I mention that we covered yesterday that are undefined arithmetic operations? What is something that we did yesterday that answers this question? No one recalls. No one got note of this information.
Miss, what was the question again?
Want to know find. The internet will not give you the correct answer. There is a little information on undefined and defined in the internet, but remember, undefined are just the basic operations. Why they are straightforward? 3 plus 3, 4 times 2. They already tell you what you need to do. You are not combining any other operation, right? So to conclude our lesson, can you predict what will be tomorrow's topic? Let me hear your ideas. What do you think we will cover tomorrow?
Arithmetic, Miss.
Arithmetic, says Ernest. Who else wants to give it a try? What will be tomorrow's topic? Anyone has any predictions for tomorrow's topic? Ernest has said arithmetic. Anyone? Geometric, says Mariel. Continuation of symbols. Okay. Ordered operation. Okay, Yuri. I think Yuri is really taking a look at the classwork in Google Classroom, right? And some of you are not doing that. Okay, so I have okay, so I have seen most of your predictions now. What could you have done better in today's class? What could you have done better? Maybe you could have listened more, maybe record more information, or anything that you could have done better in today's class. You can either type it in the chat box or unmute yourself and say it. No, we still have 2 more minutes, Mariel. Well, in my clock, that's why I'm still with this question. What could you have done better in today's class? Alan says he did everything good. Okay, that's very good for you then, Alan. Who thinks that they could have done to participate more, says Ryan. Okay, very good. That is a good thing. Yuri says write more notes in my book. So if you are aware that these are the things that you could have done better, then that means that tomorrow you can do these things, right? So anybody else just before our class ends? I just had 2 persons telling me what they could have done better. So as I mentioned, pay more close attention. That is very true, Ernest. You could have pays more attention. It looks like you were kind of distracted, right? But as I mentioned, whatever you didn't do in today's class, you can do tomorrow. So that is the idea of this question, for you to reflect on what you could have done better and just do it tomorrow, right? So that is the end of today's class session. I hope you did understood and enjoy, and we will be back tomorrow and we will see who predicted correctly, right? So that is the end of our class session. You guys have a good rest of the day.
Bye,
Goodbye,
Miss.
Yuri.
Bye, Miss Mai.
Thank you, Ryan. Goodbye. Goodbye,
Yes.
Gerard. Goodbye, Ernest. Bye, Edwin. Thank you, Rani, and goodbye.
Bye, Miss Crystal. Bye, Miss Mai. Have a blessed day.
Thank you, Ryan. Goodbye. Goodbye, guys. Thank you, Loriani. Same to you. He is my supervisor, Gerald, for UB, right? Goodbye, Yuri. Goodbye, Isari. Thank you, Kennedy. Goodbye.
Bye, Miss Ma. Bye, Miss Catzim.
Goodbye, Pascual. Goodbye, Gerald.